At Cloud NC, we've applied a new update to Cam Assist that really improves how it copes with roughing. At first glance, roughing may seem like a simple thing for a machinist to get right, as you're basically getting rid of the metal that is not needed. But it's hard for the AI because there's so many possible ways of doing that, and it doesn't always get it right. The importance of a good roughing strategy is often overlooked. A roughing process should efficiently remove all excess material, while leaving a uniform amount of stock on all features of the part in preparation for finishing. It is critical that the part is roughed out correctly to finish the part successfully. So let's take a look at what next-gen roughing brings to the table. In this example, Jay is going to run this part in both the old version and new version of roughing within Cam Assist so we can see the differences and improvements made. Alongside the milestone improvements to roughing, the next generation release also advances the output from the automatic direction mode when using 3+2 axis machining. This streamlines the setup process, as the user no longer needs to manually select faces to control machining direction for a good output. Our next generation roughing update selects the size of a tool more intuitively to suit the geometry of the part. This means that the roughing tool selected will be more proportional to the amount of material being removed. After all, using the biggest tool you have in your database to hack away material is not always the best option. Bulk roughing and detailed roughing are consolidated into one machining strategy. This in turn reduces the amount of tools, individual strategies, and tool changes within the entire roughing process. In previous generation roughing, you can see excessive material has been left in the corners due to the size of the tool selected. Yet in our next generation roughing, you can see that all excess material has been removed due to a better choice of tool. Even after a switch to a smaller tool, previous generation roughing still leaves excessive rest material in the corners and on the floor. Yet with next generation roughing, all this material has been removed. In previous generation roughing, small depth cuts are used to inefficiently remove angled faces. Next generation roughing uses 3+2 indexing to leave a uniform amount of material on the angled faces. Unnecessary whisper cuts are performed in previous generation roughing due to there being no toolpath boundary limitations. But as we can see in our next generation roughing, a contained toolpath means the elimination of unnecessary toolpaths and whisper cuts. As you can see from the toolpath comparisons, next-generation roughing produces an improved roughing strategy more along the lines of what is expected by machinists. You'll also notice in this example that the cycle time has been reduced. However, it is important to remember that this update aims to improve the overall quality of the roughing strategy generated by Cam Assist and does not always result in reduced cycle time. Overall, the resulting output will require less editing before this part is ready to go to the machine, which means more trust in the outcome, helping Jay to be more productive. Give Cam Assist a try today.